Question 680. Here we have integral from 1 to infinity 1 over x cubed dx. If the interval of integration is not finite, this integral is called the improper integral, and this improper integral represents the area of an unbounded region. Let's look at the graph of this function. So we have x-axis here, y-axis here. 1 over x cubed looks like that, right? It's a rational function. So from 1 to infinity, 1 to infinity represents this area, right? The unbounded region. So in order to solve this improper integral, we could use limits. Instead of infinity, I'm going to write a. So that is equal to integral from 1 to a, 1 over x cubed dx, with the limit a is approaching to positive infinity. Okay? We say this improper integral is convergent if the limit is finite, or divergent if the limit does not exist. So let's try to solve this. This is equal to limit a as a approaches infinity from 1 to a. We're going to rewrite this expression. That's x to the power of negative 3, right? So now let's find the antiderivative of x to the negative 3. That's x to the power of negative 2 over negative 2 from 1 to a, right? So that is equal to limit as a approaches infinity. Well, that's negative 1 over 2 times x to the power of negative 2, right? So if we substitute a for x, that's going to be 1 over a squared minus 1 for x, 1 over 1 squared. So that is equal to negative 1 over 2 times, what's the limit of this expression as a approaches infinity? Limit as a approaches infinity, 1 over a squared, that's a 0, right? 1 over infinity. So that's 0 minus 1. So that's going to be equal to negative 1/2 times negative 1, positive 1/2, which means the area of the region under this curve is approaching, converging to the value of 1/2, right? So the answer for this improper integral is equal to 1/2, or we can say this improper integral is converging to 1 over 2, right? Question 682. We have improper integral again. This time, both the left and right sides are not bounded. If we graph this function, it looks like this, right? Here's the 4, and it will approach 0 like this. It will approach 0 like this. So this improper integral represents the area under this curve, right? So as you see it, both the left side and right sides are not bounded. In this case, this improper integral must be written as the sum of two different improper integrals. It could be equal to integral from negative infinity to 0, 4 over x squared plus 1, plus from 0 to infinity 4 over x squared plus 1 dx. This upper limit and lower limit doesn't have to be 0. It doesn't matter if you use any real number other than 0. However, it is recommended to write numbers that are easy to calculate. Okay? Now let's solve these improper integrals. So that is equal to, we have this limit, right? So limit as a approaches negative infinity. Here, this is negative infinity, right? So I'm going to write a for negative infinity. So limit as a approaches negative infinity, integral from a to 0, 4 over x squared plus 1 dx, plus limit, this time I'm going to write b. As b approaches infinity, instead of infinity, I have b. Integral from 0 to b, 4 over x squared plus 1 dx, right? So that is equal to limit as a approaches negative infinity. Here, antiderivative of this expression is actually equal to inverse tangent, right? Think about this. Integral 4 over x squared plus 1, that's 4 times 1 over x squared plus 1 dx, right? So that is equal to derivative of inverse tangent is 1 over x squared plus 1, right? So antiderivative of this is 4 times inverse tangent x. Do you see that? So that is equal to 4 times inverse tangent x from a to 0 plus, we have limit as b approaches infinity, again 4 times inverse tangent x from 0 to b, right? So that is equal to, here we have a 4 times limit as a approaches negative infinity, that's inverse tangent 0 minus inverse tangent a, plus 4 times limit as b approaches infinity, that's inverse tangent b minus inverse tangent 0, right? We know the inverse tangent 0 is equal to 0, right? So this is a 0. This is a 0. What's inverse tangent a as a approaches negative infinity? Let's think about this graph right here, the graph of inverse tangent. It looks like that, right? There are two horizontal asymptotes and it approaches these two horizontal asymptotes. This is pi over 2. This is negative pi over 2, right? So as a approaches negative infinity, this inverse tangent approaches negative pi over 2, right? So this is negative pi over 2, right? Here, what's inverse tangent b as b approaches positive infinity? As b approaches positive infinity, it approaches pi over 2, right? This approaches pi over 2, right? So that is equal to, let me write right up here, okay? Since we don't have enough space. So that is equal to 4 times 0 minus negative pi over 2 plus 4 times inverse tangent b, that's pi over 2. So pi over 2 minus 0. So that is equal to 4 times 1/2, that's 2. So 2 pi plus 2 pi, right? So the answer is equal to 4 pi. That's our final answer. Question 684. We have definite integral from 0 to 1/2 x over 4x squared minus 1. We can use u substitution to find the antiderivative of this. Let u is equal to 4x squared minus 1. Then du is equal to 8x dx, right? So I'm going to multiply by 8 here, 1 over 8 here. When x is equal to 0, here the lower limit, our u is equal to 4 times 0 squared minus 1, which is equal to negative 1. When x is equal to 1/2, upper limit, then our u is equal to 4 times 1/2 squared minus 1, right? So that's 1 minus 1 is equal to 0. So we have integral 1 over 8 from when x is 0, use -1. So -1 to 0, 1 over u du, right? This is our u, and 8x times dx, that's our du. So far so good. So we have a definite integral from -1 to 0, 1 over u du, right? But when we look at this function right here, this function has vertical asymptotes, right? The function 1 over x looks like, well, x actually it's 1 over u, right? Here's the u-axis, here's the y-axis. It looks like that from -1 to 0. So we are actually looking for this area, right? But as you see, we have a vertical asymptote here. So the right side is not bounded. So this is also improper integral, right? So we're going to have to use limits 1 over 8 times limit as a approaches. Now it approaches 0, right? It approaches 0 from left hand side. So approaches 0 from left hand side. Instead of 0, I'm gonna write a, right? So we have integral from -1 to a, 1 over u du. So that is equal to 1 over 8. Well, antiderivative of 1 over u is just a natural log u, right? So natural log u from -1 to a. So 1 over 8 limit as a approaches 0 from left hand side. That's going to be natural log a minus natural log -1, right? This is natural log 1, right? Natural log 1 is equal to 0. So this is just a 0, right? What's this value right here as a approaches 0 from left hand side? Think about this. If we graph natural log x, that looks like, here's x-axis, here's the y-axis. So graph of natural log is, it looks like that, right? So as a approaches 0 from left hand side, think about this. If this is -0.1, -0.01, it approaches 0, right? But we have absolute value here. So it actually approaches 0 from right hand side, right? Here, 0.1, 0.01, right? It approaches 0 from right hand side. So as x approaches 0 from right hand side, it approaches -infinity, right? So this value, this limit value is actually -infinity. So we have 1 over a times -infinity. That's just -infinity, right? So this improper integral diverges. This improper integral diverges, and the answer is -infinity. Question 697. If a is the reason between the graph of g and the x-axis for x is greater than or equal to e, what is the area of a? Here we have xy plane, and the graph of g for x is greater than or equal to e is, let's say here's e, and it'll decrease like that, right? Eventually it'll approach 0. So we're trying to find the area of this unbounded region, right? So the area A is equal to integral from e to infinity, improper integral, 1 over x natural log x to the power over 4 dx, right? We are going to use substitution to solve this integral. So let u is equal to natural log x. Then our du is 1 over x dx, right? When x is equal to e, this lower limit, then our u is equal to natural log e, which is equal to 1 when x is equal to infinity, upper limit. Then our u is equal to natural log infinity, which is infinity, right? So that is equal to, from 1 to infinity, here this part right here is u, right? And 1 over x dx, 1 over x dx, that's our du, right? So that's going to be 1 over u to the power over 4 du, right? Now we're going to use limit. Since this is improper integral, instead of infinity, let me write a. So we have limit as a approaches infinity from 1 to a. 1 over u to the power of 4, that's going to be u to the power of negative 4, right? So that is equal to limit as a approaches infinity. Antiderivative of u to the power of negative 4, that's going to be equal to u to the power of negative 3 over negative 3 from 1 to a, right? So that is equal to limit as a approaches infinity, negative 1 over 3. I'm going to substitute a for u, okay? Substitute a for u. Then that's going to be a to the power of negative 3. That's 1 over a to the 3, right? And substitute 1, that's going to be minus 1 over 1 to the power of 3, right? So that's going to be equal to, here, think about this limit value. As a approaches infinity, 1 over a cube is approaching 0. It's a 0, right? 1 over infinity cube, that's 1 over infinity that approaches 0, right? So we have negative 1 over 3 times 0 minus 1. So that's going to be negative 1 over 3 times negative 1, positive 1 over 3. All right, so the answer is positive 1 over 3. Question 699. Assume h is a differentiable function. If h of 2 is equal to 5 and limit as x approaches infinity, h of x is equal to negative 1, what is the value of this improper integral? Improper integral can be written in terms of limit, right? So limit, let's say a approaches infinity. Then this infinity is a. So we have integral from 2 to a, h prime of t dt, right? So that is equal to limit as a approaches infinity. The antiderivative of h prime is equal to h, right? So we have h of t from 2 to a. So that is equal to limit as a approaches infinity, substitute a minus substitute 2, right? So that is equal to, here, limit as x approaches infinity, h of x is equal to negative 1, right? It's given. So limit as a approaches infinity, h of a is equal to also negative 1, right? So we have negative 1 minus h of 2 is 5. So negative 1 minus 5, that is equal to negative 6, right?